So, shall we start?
Yeah, all okay. Yeah, please, we can.
Okay, sir. Thank you. So, welcome to all the participants to the third expert session of the Geotechnical webinar series, Advanced Testing Technologies for Geotechnical Investigation, which is hosted combining by Civil Engineering Department JUIT Vaknaghat in association with IGS Shimla chapter. Myself, Sanjay Singh Parihar, Assistant Professor in Civil Engineering Department, JYT Vaknaghat, along with Mr. Rohan Singhal, who is my colleague, will be hosting this entire webinar series. Now, on the behalf of entire JYT community, Civil Engineering Department JYT and IGS Shimla chapter, we would like to welcome our geotechnical expert speaker of the day, Mr. Sanjay Gupta ji. Welcome to you, sir. It's a cherishing and proud moment for all of us to have a renowned person like you with us on IGS Shimla chapter. Giving a brief introduction about him, Mr. Sanjay ji, BTech and MTech from IIT Delhi, and currently founding and managing director of Cengrs Geotechnica Private Limited, owns an outstanding record in field of geotechnical engineering and has imparted his valuable contribution in both the fields of practicing industry and research. Being the founder of Cengrs Group in 1983 and Cengrs Geotechnica Private Limited in 1990, he has a massive over 50 years of experience on about 6,500 projects as a practicing geotechnical engineer, striving to bridge a gap between the research and practice. He is a fellow and active member of top national and international bodies such as IGS, CEAI, IRC, and ISRMTT. As technical committee member of BIS, IGS, and IRC, he has been involved in upgrading profession and drafting of various codes of practice of BIS and IRC. He has served as member of Engineering Council of IGS for 4 terms. He has also been the chairman of IGS Delhi chapter between 1999 and 2001 and served as co-chairman of Golden Jubilee Conference IGC 1998, in addition to being member of various technical and task committees of IGS. His wide range of expertise includes site investigations, ground improvement, foundation solutions under difficult soil conditions, including soft ground weak soils, collapsible soils, expensive soils, and soils under artisan conditions. Widely regarded for his experience in the field of geotechnical engineering, he is a recipient of various important recognitions. To name a few, he received the Best Paper Award in IGS AG Dastidar Biennial Award in 1994 for Best Paper on Ground Improvement. He got IGS Dinesh Mohan Award for Excellence in Geotechnical Practices in 2008. He is also a recipient of a Lifetime Achievement Award in 2010-11 by IGS Delhi chapter. He is an awardee of IGS Shri MS Jain Biennial Award in 2019 for Best Paper on Innovations in Piling and Other Foundation Construction Techniques, presented at 19th International Conference at Seoul 2017. He has published and presented over 70 technical papers on geotechnical field aspects and has delivered keynote and invited lectures at various national, international conferences, seminars, workshops, including training programs of CRRI, NITHE, and Institution of Engineers, and various IGS local chapters. He also has been involved in promoting and specialized and advanced testing services like static cone penetration test, pressure meter test, cross-hole seismic test, etc. on various projects for more reliable data to add value engineering and meet serviceability criterion with higher factor of reliability. With this note, I would like to invite our guest speaker of the day, Mr. Sanjay Gupta sir, for today's session and request him to proceed with the third lecture of this geotechnical webinar series. Over to you, sir.
Yeah, Good afternoon to all. अभी तो वो देंगे ना. Mr. Neeraj, should I start?
Yes, sir, definitely. Please.
Screen पे आ जाओ. मेरा screen. Laptop पे screen. एक
अभी खोला नहीं आपने?
हाँ.
Okay, in the meantime, we have done important information for the participants. Many of the requests have been coming to us for the missed out lectures, past two lectures who have missed out. We will soon be sending a link to the participants so they can attend those lectures.
Yeah, now you can proceed.
Yes.
Okay.
Yeah. Good afternoon to all. Is it visible? My screen is visible?
No, sir, you can't see your screen now.
Oh. Can you see it now?
Yes.
It's visible, sir. It's visible.
Okay. You can see now,
Yes, sir.
right?
Yes.
मैं इसको zoom. एक मिनट रुको ना.
6 स्लाइड एक साथ आ रहे हैं.
ज्यादा बड़ा.
मैं प्रेजेंट करूंगा यहाँ पे.
एक मैं इसको कम कर दूं थोड़ा सा.
It's not in the presentation mode.
Is it coming?
It's not in the full
not
screen
in the
mode.
presentation.
It should be on presentation mode now.
No. It's not in the full screen mode. At the bottom, you see that cup and saucer. The slider bar. The left of slider bar, there's a cup and saucer kind of a picture. At the bottom slider bar. To the left of that, there's a kind of cup and saucer kind of or a cup kind of a picture. That you have to click. Or you have to press F5 on the keyboard. Function key F5 on the keyboard.
Is it coming now?
It's still not in the full screen mode. I don't know about others.
Sir, I think you have to share the entire screen. Yes, sir. On the Gmeet, you have to share the entire screen.
Sanjay Sahab, on the top you have slideshow. Top
हाँ जी.
menu.
Yeah.
Menu. Top animations के बगल में you have slideshow. Top. If you can click that, maybe on the top animations के बगल में there is slideshow. That maybe you can try.
Yes, sir. Your screen is visible now. Uh,
Is it okay?
it's not on full screen, sir.
It is not on full screen. Alright. Okay. Well, good
Uh,
afternoon to all of you. First of all, we at Cengrs are very thankful to JUIT and igsshimla chapter for being part of this webinar series on advanced testing technologies for geotechnical investigation. The topic, which is very close to our heart over last more than 30 years, as we have been trying to promote use of advanced testing techniques in the industry to implement and adopt it in the practice. Well, this webinar series has got 5 lectures, presentation. The first one is Advanced Testing Technologies and Introduction, which was presented by Mr. Ravi Sundaram. The second is on static cone penetration test, presented by Mr. Saurav Gupta. The third one of the series is on pressure meter test in geotechnical design, which is being taken up today. After this, we have the fourth one and geophysical testing for geotechnical analysis to be presented by Mr. Ravi Sundaram. And the fifth one, yeah, ah, the fifth one shall be on energy measurement for SPT, which will be presented by my other colleague, Mr. Ankit Puniyal. Well, before I start, all right, now, now all these technologies, whatever these 5 chapters we have mentioned, shall be covered by illustrated by various case studies to demonstrate the field application and the engineering benefits. Shall we? Yeah. Well, let me start with the first one of my very, very old and a favorite slide. You know, the project I always compare with the human body. As for the human body, we have the different parts in the body. Similarly, the projects have different components, right? Now, as we talk about the human body, what us are aware of, we have the heart for which we have the specialists like cardiologists, right? Similarly, on the projects, we have various structures, you know, the structures and other things, but mainly we are concerned with the foundations, which is related to geoprofessionals. So I'm trying to say that we geotechnical engineers are as good as a cardiologist on the for the human body. Right? Now, as we all know, for the human body, we have been doing, you know, the earlier days, only the pulse rate, temperature, and the some few blood tests, urine tests were only the items which the people were, the doctors were asking for. Now, if I take what is the current trend, the pathological investigations are now supplemented along with the blood pressure, and then they go with the CAT scans, MRI, etc. Similarly, in geotechnical investigations, we have been doing boreholes, dynamic cone penetration tests, plate load tests. But now, with the advancement in techniques and the technology, What we have is a pore penetration test, pressure meter test, and other things. Well, basically, why do we want all these things? Like the doctors, why they ask for all these tests? Because they want to reduce the factor of ignorance, to identify the ailment, to give you a proper treatment. Now, you remember that no two human bodies are same. No two the disease can have, the same type of a medicine. One medicine which is suitable for me under high temperature may not be suitable for you. Similarly, in the geotechnical field, it is not that a one test, whether we call it any particular test, that will suffice and replace all other things. No. As we go forward, you will realize that all these things are quite interrelated, and one has to take the judicious judgment. Basically, what we are trying to reduce the factor of ignorance. And as we are able to, as Mr. Ravi had mentioned in the first date, that the level of investigation ranges from bronze to platinum. That way, the moment I am I'm using the word appropriate test, reduction factor is also increases. That means my factor of ignorance reduces. And if my factor of ignorance reduces, I will have a better performance of the structure, more economic. Now, coming back to our main topic of today, that is the Maynard pressure meter. The pressure meter testing technique was developed or rather invented by Mr. Louis Maynard, right? The inventor of pressure meter test. In 1954, as a student, he himself set a goal of developing a single test for to measure the ultimate pressure of the soil and its deformation modulus in order to calculate bearing capacity and settlement. One minute, इसका वो कैसे चेंज नहीं हो सकता? नहीं, ये जो डॉट वाला आता है. पहले तो वहां पे आ जाता था. छोड़ो. Sorry, I'll proceed. So he developed, the and filed a patent for the device that has revolutionized geotechnical practice. In 1957, he set up his company as a lead pressurometer Maynard to market the product. Well, the success soon followed, and pressure meter became popular in France with 4 licenses using his devices. So just to give you a background of the development of pressure meter in the worldwide. In 59, Maynard exported the pressure meter to Belgium, Germany, Sweden, Canada, and Brazil. Soon it found acceptance worldwide. Over the years, the original model underwent several modifications, improvement that is quite obvious, and it has to happen. In 1975, the GA and GC type pressure meters were developed. Very much evident by the advantages that we could get with this test. Well, it is the in situ testing method used to determine the stress strain as the Maynard pressure meter test is performed by applying pressure to the side walls of a borehole and recording the corresponding deformation. It involves drilling a borehole and placing a pressure meter probe to the required depth. The probe consists of 2 inflatable cells, a measuring cell which expands as it is filled with water, and a guard cell which is filled with gas which protects the measuring cell from shocks and impacts. Other types of equipment that measure change in diameter of the probe with pressure are also available in the market. Well, now coming back, the pressure meter are of 3 types, There's the first one is a pre-bore pressure meter, which is the most common, and we have been performing and using the same method or the equipment in India till date. Other one is a self-boring pressure meter. It has a probe that is self-bored into the ground to prevent disturbances. Well, it becomes a faster over pre-bore pressure meter. Then there's a third one, which is a pushed-in pressure meter. It has a cone-shaped probe that is inserted into the base of a borehole hydraulically, usually with CPT rig. It displaces the soil into the cone of the probe. It causes less disturbance to the soil. This one is the third one is quite like, the dilatometer test. And I'm sure whether maybe a few years down the line, where Sanjay should be able to provide you some more field data and the actual field results comparisons with the dilatometer also. Well, just to make a comparison, the self-boring pressure meter gives more accurate and realistic results because the disturbance to in situ stress is minimal. But the equipment is very expensive as of date. Maybe after a few years, it may become, within the tolerable range of the cost to a is not very popular since it may not work in hard soils. In India, pre-board pressure meter is used on most of the projects, and this presentation is limited. Now we talk about one question comes to my mind. While we are looking for the advanced testing techniques, whereas we have been using the SPT till date over the last so many years. So why should I spend more money to do it? The SPT, standard penetration test, is the most trusted test, right, as on date. But it is also the most abused test in industry. As it has been presented in the first lecture itself, rather presentation, you see, it all depends upon the moment, the type of the equipment you're using, the whole thing depends upon the free fall of that SPT hammer. Of equipment you are using and the people who are working at it, it all depends upon, the friction between the pulley and the friction between the guide rod and the drop weight, and also the fatigue level of the workers hoisting the manila rope or the wire rope for lifting and dropping the SPT hammer. So that means, and also, that SPT shoe, the most important in SPT is the drill rods, which are connecting the split spoon sampler to your drill rods coming up to the ground level, right? They may have a buckling, they may be, shifting from one place to place, and the verticality. All these things matter a lot as far as we come to the realistic value. Now, we at Cengrs, in the last 10, 12 years, we have developed our own method for the auto trip mechanism, just to ensure that a free fall thing and a fixed height, these two aspects are taken care of, without depending upon any, the fatigue of the workers or any other issues. Now, coming back to our main topic of pressure meter, this is just to give you, why we are looking for the advancement in testing technique. Is drilled, stress release occurs when the material is removed from the borehole. The stress release is restored at least partially during the test if the test is performed soon after the borehole is drilled, right? This is important one. The effect of the load-unload cycle will exist in pre-board test, quite obvious. In situ stresses are maintained in self-boring pressure meter, but the cost of equipment is high. If the cost of equipment is high, the cost of the test also will be high. Now, the borehole preparation, the disturbance is caused by the drilling equipment along the walls of the wall. is a function of drilling equipment and tools used. Naturally, in a firm to stiff clays, use rotary drilling with bottom discharge within bentonite slurry circulation. In soft clays below water table, with bentonite slurry or water table. In weathered rock, use only and only hydraulic rotary drilling rig. Well, in all cases, one must advance the casing to just above the test depth so as to ensure borehole does not collapse and probe can be recovered after the test. This part is very important and one has to take note of it because, because the probes are quite expensive here. Till date, the main suppliers, they are all saying that they are importing from France. So the cost goes up. Well, most important part is that we have to maintain a correct diameter of the borehole. If the diameter is not correct, your pressure meter test results will all be wrong. Yeah. Well, in the pressure meter test, am I audible again? Yeah, okay. A control unit is set up near the borehole to pump water and gas while recording the measurements. A coaxial hose connects the pressure meter probe to the control panel. The inner hose carries water into the measuring cell. The outer hose carries gas, usually carbon dioxide or nitrogen, to the guard cell. As the pressure increases, the borehole valves deform. The pressure is held constant for a given period, usually 1 minute, and the increase in volume at a constant pressure is recorded. Now, this is just the test set. And this is the assembled probe. Control panel. It has got a measuring cell gauges, it has got a stopwatch, it is a volumetric. This thing just to measure the volume changes. There's a card.
Presentation.
Sorry?
You need to put it on presentation mode.
क्या हुआ यार ये? Next one. Why it is not coming?
Who's this? Not presenting.
Is it coming okay?
No, sir, it's not in full screen mode.
हाँ इसी को तो क्या था? इसी पे चल रहा था. Is it coming now?
No, sir. No, no.
No, sir.
No. At the bottom of the screen, there's a slider bar. At the bottom of the screen.
Yeah, from there only we have done it.
Okay. Maybe there's a lag, I guess. Lag. Internet lag, or maybe I don't know.
Sir, you may try sharing your entire screen on Google Meet. It might work then.
We have,
Yes, sir.
we
Rather
were
than
doing on
sharing
the
the entire screen.
entire screen.
First, you have to stop sharing them.
Is
First.
it?
Yes, sir.
First is
Please
optional.
stop sharing. Yes.
Okay.
Okay, entire screen करके then you go.
इसमें तो वो आ रही है ना.
वो पूरा आने दो मेरा screen. ये वाला screen आ रहा है ना? नहीं नहीं. Opening that PPT.
तब तो ये पूरा स्क्रीन शेयर. Slow.
नहीं आ रहा ना?
Yes, now it is perfect, sir.
Now it is good.
Stop sharing करके.
Now it is fine.
Now it is fine.
Oh, no. Yeah, it was.
It was.
Yeah,
Not
now
now?
it is fine. Perfect.
Now it
Yes,
is fine.
now it is fine.
Okay, okay. Thanks. Is it okay? Yeah, okay. So we were talking about this control panel. So here is the regulator. There's a pressure gauge for the gas cylinder. And this is a coaxial hose. You know, this one is going to the probe and this one is going to the gas cylinder for giving you the pressure. Now, the equipments of capacity up to 200 bars are also available worldwide. 200 bar means 200 kg per cm square. However, so far we have been using only 80 bars capacity of the equipment, which is suitable for hard soils and the weather rock. 200 bar equipment is more suitable for medium to hard rocks. Since bearing capacity and settlement is not a problem in hard rocks, 80 bars equipment is suitable for most of the applications. Right? Now the standard diameter is of an exercise which includes in India. Now, talking of the probes are of two types. You know, one is the rubber and the other is metal. Metallic probes you use for the rocks for 80 bars pressure. Rubber ones we use in the soils up to 25 bars. This is just the photograph showing you about a pressure meter probe. There's a soil probe, there is a rubber probe, right? This is the outer cover, there's a hole where he's going to insert. It has got a coaxial cable here connected. And this is a rock probe with the outer cover of the steel stirrup. It is to high pressure. So naturally you require a cover of the steel. This is just a close-up view. You can see this soil probe. You can see this connector, you know, for the coaxial cable. There are two pipes here. This is a rock probe, right? Now this, as you have understood that your probes and the coaxial cable, they are all, you know, the flexible materials, right? Probes are with the rubber, so they will have their own, you know, the stiffness, expansion properties, or the pressure losses. So we do need the calibration of the probe. Now there are two types of the calibrations which require. One is the calibration, which correlates with the stiffness of the rubber part, that means the pressure. How much pressure one loses when you are expanding the probe. Similarly, you have another one known as a pipe calibration. It is for the volume loss, for the expansion, you know, in the coaxial cable, etc. Whenever you are putting the pressure, there will be some volume loss. So remember, these are the two corrections, the air calibration and the pipe calibration, which we need to have on site prior to conducting the test. Now let me quickly take you over to the, you know, the flow diagram, what all it, you know, so we will see the three different things, you know, the panel, the gas cylinder, and the probe. Now, how everything goes together. Emergency. So please, the pressure meter test unit, as we talked, you have a control panel. Control panel is basically to measure the water changes, the pressures. Now, these pressures you have to measure for the guard cell, which is the gas and the patient cell, and the water cell is connected with the volume changes. Right? All this generally is now combined with coaxial cable, which goes here. Now, this one is going to the radially expanded probe. pressure meter unit? Yeah. Is it coming now? So I'm able to change the slide. Okay. Okay. So I think there are some issues. So in the radially expandable probe, you have two parts, right? As we discussed initially, there's the inner membrane, outer. Outer cover is the parts, right? And the measuring shell. Measuring shell, this one is inflated by water, right? And the guard cell is inflated by gas, carbon dioxide or nitrogen, as the case may be. You can use any of the two. Basically, what we require is an inert gas. So what are the steps involved? For air calibration, you expand the probe in air. Some pressure will be required to expand the membrane, as I just explained. The net pressure on soil is the difference between the measured pressure in situ and the pressure for expansion in air for a specified volume. That's, I think, quite clear. Now we come to pipe calibration. You expand the probe inside the stiff steel pipe. Since the probe will not expand in the rigid pipe, the volume change is the expansion of the hoses. Volume change is also corrected for expansion of hoses. Now we first thought, the pressure versus volume of the field curve, whatever the in situ we are measuring. Then we apply the corrections for stiffness of membrane and expansion of hoses and generate a corrected pressure versus volume graph. So now, having talked about all these things, the procedure will be, you need to calibrate the probe first, then you drill NX diameter borehole. Why I'm using the word NX? NX is what commonly you're using. In case you are using AX or DX, then according probe, then according you have to drill borehole on that side. Now you lower the probe in the test section, apply incremental pressure, and limit pressure. Yeah. Again, हॉटस्पॉट पर मिल रहा है मुझे बताया
Can you repeat it? Okay, go on.
Hello.
Sir, no, we can't see your screen. We can't see your presentation right now.
Again, an internet problem.
Again, internet.
The presentation, Ravi sir has the same copy.
नहीं क्या हुआ
That's your laptop problem.
You cannot see, right?
Yes, still we cannot see.
You send your presentation to me and we present it. Ask people to hold on.
I think you have to excuse for a while, right? We are changing over the system.
Okay, sir.
Yeah, just give me few minutes. Okay.
So we can see your screen, but it's not in full presentation mode.
Now it will come. It will come.
Okay, sir.
Other one. The legend elevation.
Yeah. Can you see now?
No, sir, it's not in full mode still.
Eh?
It's not still in the full presentation mode. Sir, have you shared the entire screen?
Yes. Oh, ये भी नहीं है.
Maybe you should reschedule.
Huh?
You should reschedule.
Restart.
Reschedule the presentation.
यहाँ तो ठीक. Is it okay?
Just go.
No, sir, still the same screen is with
It's
us.
still the same problem.
Okay, just go next one.
Huh?
Yes, sir, still the same.
It's okay. Just go with this.
Not in full screen. Not in full screen mode.
But we cannot see full screen.
It's not working. And
Yeah,
full screen.
content is visible, but full screen is not there.
On Google Meet, there is some fight.
Sir, maybe you can unshare and again share this full screen.
It is full screen.
Stop करके.
Ah, it's fine. Yeah.
Now it is fine, sir.
Now it is fine.
Yes, sir.
Okay. Sorry, my apologies for all that hiccups. Well, now the test procedure is that you have to calibrate the probe, right? Am I audible?
Yes, sir. Yes, sir. You are audible.
Okay. So then you calibrate the probe. We drill the NX diameter or whatever the diameter of the probe you are using. Then you lower the probe in the test section, apply incremental pressure till limit pressure is attained. For each stage of loading, record the volume readings at intervals of 30 seconds and 60 seconds. Now, remember to maintain differential pressure between measuring cell and guard cell. That is, gas pressure is to be more than the water pressure. This is basically to guard the protect inner membrane. So the differential pressure of 1 bar, that is the 1 kg per cm square, is also okay. Right? Now, just to show you physically, this one is the drilling rig you can see, right? Now, this is the probe and this is the NX casing. Now, here you can see this is the probe which is connected with the coaxial. Now, it is being lowered into your below the casing for the test section. Well, the pressure, this is just after the test, when the pressure meter, this is how, it gets expanded. This is a closure view of the showing you the increase in diameter of the probe in the central portion. Now, this is the test in progress. Again, this you remember, this yellow box, which is your panel. There's the nitrogen cylinder, and this is the, the gas tube, and this is the coaxial cable, which is going down to the probe. Now, what are the typical results, that how we do it in the soil? As I was mentioning, that you have to do the pipe calibration and, the air calibrations, right? Now, we plot the pressure versus the volume, right? Pressure is in bar, that is kg per cm square, and this is the volume, right? So here it is the pipe calibration, we have plotted like this, and this is for the air calibration. Now, whatever in the field you are measuring the reading, the pressure versus the volume, that is plotted here by the blue line, and now you apply the correction for the pipe and the air calibration, for your change in the pressure and the volume, and you develop a corrected curve like this, okay? Now, this is for the soil, and here it is for the rock. Same exercise, you do the pipe calibration, you do the air calibration, field curve, and you come out with a corrected curve. You can notice, the difference in the curvature of these graphs. Why it is quite similar. Soil will have a deformation, whereas the rock will not have much deformations. It shows me a limit pressure of 39.6 bar. That is the limit pressure is where it is, coming to a yielding point here, right? And in the rock, it is coming here, which is about greater than 79.3, and you have a deformation modulus also. Now, once you have that one was showing you a one particular depth, right? This one is at a one particular depth, the one test, right? Now you are doing the test down the borehole at different levels. Once I have all those test results, this is how I am going to plot. These are the N values, the soil classification, and here is my limit pressures, with depth. So at whatever the depths you have done the test, all those things are plotted here. Similarly for the deformation modulus. So that means you get we call it as a PMT profile, like you've been talking about the SPT profile, the SPT variations down the depth in the borehole. Similarly, we have it here. Now, this is the typical PMT profile for the rock, limit pressure, and this, right? Quite obvious. Now, again, all our researchers, they have to spend a lot of time and energy, and they have worked out the correlations between the deformation modulus and limit pressure for different soils, right? Well, as I mean, in the earlier session, somebody said that these are the data which is all imported, for the worldwide, whatever they have done. In the different type of the soils, they've given the range of the modulus, deformation modulus, and the limit pressures, right? Basically, but in India so far, whatever we have done, it broadly covers, you would appreciate that you have quite a wide ranges, like, in the set you have from 2200 to 250. We have a wide ranges, but they all fit in fairly well. Well, it may not be out of place to mention. Even, that earlier, all your correlations with the SPT values are only, the works done abroad, outside India, but they have been applicable in India also. Right? Now, again, the limit pressure also has been correlated rather something like with the SPT values in the science. So 0 to 4, we know it is a very loose one. We have all understood it. So this limit pressure would be in the range of 0 to 2 months, right? Similarly, we have all these ranges like, we are familiar with the SPT value. So we can now, if I have a limit pressure, 5 to 15, I know my SPT value is something like between 10 and 30, right? So this is just to give you an idea that all these things are getting now correlated. Now the correlations between the limit pressure from pressure meter test, SPT, we all know, and the cone tip resistance from the static core penetration test. Cone tip is a QC. Now these are all our, available in the literature, in the various textbooks, or the balls and others. So we know that for the different type of the soils, what are the ranges we have, or what kind of the, relationship one can expect. Now let me take you to the field now with this much of the theory part. Now I want to compare my limit pressure from pressure meter test and with the SPT values, right? Do you have the correlations, whatever the literature says? Now this is what is the borehole profile with the SPT values. I got a limit pressure here at the depth. Now the red one is showing me the limit pressures as I compute based upon the SPT values correlations depending upon the type of the soil, okay? And now this is what are the limit pressures as we actually obtained on the site at the same depths, right? Now you can see that this is what is the correlated values from the SPT values, but actually what you get on the site is a much higher values of the limit pressures. Now if the limit pressures are higher, obviously my bearing capacity would be higher, my settlements would be lesser, so you can optimize your design accordingly. This is just that table, from the previous slide, whatever we had these correlations established. So that one I've just put it here to make it as an easy reference. Right? Now we talk about the elastic modulus. The same way, again the borehole, we have the SPT values here. We have computed my modulus, elastic modulus, based on the N values, again, based on your standard correlations as given in pounds or any other. This one is a slightly better. And now from there, I have converted to the elastic modulus, right? This is the one, the values given as per the, based on the SPT and values, right? And now this one is the E as per the QC, 3 SPT or 3 times the QC values. And this one is the one, the triangle, green triangle, are the modulus values as per the pressure meter results, okay? So, and this one is this continued line here, right, is from the static core penetration test. So what you can find here, that the modulus values, the elastic modulus, as obtained from my pressure meter test, right, and as obtained from the static core are fairly okay here, right? But here, the difference is that this static cone could not go beyond 14 meters, right? Maybe it attained a refusal of the capacity of the penetrometer static cone instrument, but a pressure meter, I could take it down to 30 meters. Right? So that's the advantage of it. Now let me take another example just to show you, how these values correlate. Is a site near Lucknow. I will not name the project name because of the confidentiality issues. This is the borehole data. You have the AND values. Again, the same. These are the limit pressures computed based upon the SPT values as per the correlations established, right? And these are the actual limit pressures obtained, which are much higher than the correlated one. I hope I am audible and not going very fast or not too slow. Please let me know. Mr. Neeraj?
Yes, sir. Yes, sir. It's perfectly fine.
Okay. Now, similarly, I've done with the elastic modulus. Right. Now, elastic modulus, again, based on the N values, and then you have the, as per the pressure meter, is this green ones, right? These are the elastic modulus. And this red line is for the static cone. Now, here you will find in this particular site, the static cone is giving me a slightly higher modulus value as compared to the pressure meter. That one was showing up to the, this one is shown up to about, the 94, about 60 meter depth, and then the below this, I'm showing you here. So it is going right up to 90 meter depth or so, right? So this is what it is. Now you can see that we could have a pressure meter test right up to the bottom, whereas the SPT values were giving a refusal, so we could not do much beyond that. Now the pressure meter test, whatever we have explained about the the variations, etc., one can use it for to determine undrained shear strength of trees. You can determine consolidation parameters, in situ horizontal stress, shallow foundation analysis can be carried out based upon pressure meter tests. You can do the bearing capacity computations. You can do the settlement analysis. Similarly, one can do the deep foundation analysis, like the pile foundations. You can do the pile capacity. You can do the settlements. All those things can be used, can be carried out by using pressure meter test data. Well, there are another advantage is that this is the one test by which I can determine up pressure at rest, which is the K0 value. So let me quickly take you to the advantages, whatever briefly I have explained about the pressure meter. You know what, all these things, what I was talking about, the computation of undrained shear strength or the shallow foundation. I mean, there are established equations and we have been using it. For just to save the time, I'm not coming to those slides. In case it permits, I'll show you the equations. But of course, each one will require more than an hour to explain the total procedure. So this is just to tell you, but I want to concentrate on to some case studies to show you that in the field, what advantage we got by using all these methods. Well, the advantages are, I think, which is quite obvious, but with whatever we have been talking of in the last whatever the time, you can get in situ stress sustained behavior of soil and rock quite precisely and accurately without causing, with the minimum disturbances to in situ conditions. Hence, the quality of results is superior. As a more realistic behavior analysis for open and pipe. Naturally, if I know the actual soil conditions, the strata conditions, the behavior, whatever we predict, can be a more realistic. I can determine, this point I've already stated, in situ coefficient of earth pressure at rest. Now, in weathered rocks, where core recovery is poor, pressure meter test is the only test which can give you any realistic data. When the core recovery is poor, naturally you cannot carry out any tests like the crushing strength or other things on the point load. So this is where you have the advantage with the pressure meter test. Well, everything cannot be so good. One can always have the limitations. It cannot be conducted in boundary strata. That's absolutely fine, because in between the boulders there is a soil matrix. So the probe will expand into the soil matrix, but the boulder will restrict its movement, and with the result you will not get any realistic value. In sandy strata, it is difficult to conduct the test because of the borehole collapse, right? You may, for the one test, you may have to repeat 2 or 3 times. So as such, in sandy strata, the cost for performing the test goes up. In fracture rods, of course, this is the best test for the fracture rods because this is the only way I can determine some parameters. It may become, the membranes may get damaged, if the membrane gets stuck between the fissures. So the cost of test is more because of your loss of membranes. Now with this one, let me go to some case studies. I will just take up 3 case studies. One is the Khalsa Heritage Complex, Anandpur Sahib, Punjab. Another one is the Panipat Refinery, and the third is the underground section of Delhi Metro. So the first one, Anandpur Sahib, Punjab. Well, this is the Khalsa Heritage Memorial Complex at Anandpur Sahib, Punjab. It is very close to the famous Keshgarh Sahib Gurdwara at Anandpur Sahib. It is a tri-massive structure. It has got unique architectural features, epitome of traditional Sikh elegance, so beautiful and impressive. Is a wonder of modern civil engineering. Well, this is how it was a perspective view. This is a Nishane Khalsa, which is the typical of your Nishane Khalsa. Complex C is there, complex B. This is a bridge connecting between the 2 areas. This is the complex A. I do have a photograph of completed one. And of course, when we are talking of your Himachal Pradesh area, I think if you take the Bilaspur side road and it's 21 or 22, you go past by this area, right? So one of you must have seen this one because it is now existing. It has been now completed. Well, complex A is the library and associated. Complex B is that bridge I mentioned. Complex C is exhibition hall, theatre, link. Nishane Khalsa is a tall tower structure. Now, this is how is the layout plan, giving you in that both the areas, complex A, complex C, and this is the B is for the bridge, various test locations. Here, what we have done is the boreholes, we have done pressure meter test, we have done the static core test. Well, it is on the bank of river Satluj, it is the alluvial in nature, it's a foothill zone of Himalayas, low rising hillocks of soil. What is the stratigraphy? It has got a sand mixed with pebble shingles in intermediate areas. Right? There's a scope, 15 boreholes, 15 static core, and the pressure meter test. Now, this is what is the view of the site. These are the kind of the hillocks we are talking about. Well, this is you can see the typical profile for the complex C. All these boreholes you can see are starting from the different levels because of the terrain. So we have done all this investigation, right? Now this is the field SPT values. They have been all plotted, with respect to the RLs, so that we are top of the one particular level for all the boreholes here. This is a pressure meter data. These are the corrected curves at different depths, right? So now you can say that 18-meter depth, this is what is my limit pressure. Now as you are going deeper, your limit pressure is also increasing. And at 26 meter, it goes to something like about 26 bar as the 27 bar is the limit pressures. Right? We obtain the sufficient data of high quality, right, with a greater reliability of the parameters. Now we use SPT values for the analysis. We use the static cone tests, QC values, the classic theory, the immediate settlement and consolidation settlement. Since no closed clay zones are met, so total settlement is equal to the elastic settlement. We also use the pressure meter test results. Now you will see what we got. Assuming a foundation size of 3 by 8 meters for a loading of 30 ton per square meter, now what we got from man value is a 33.6 millimeter settlement, a static cone showed us 27, classical 31, and pressure meter showed us 13.6. So now you can see the variation from 13.6, 27, and 33, right? So you got a wide range of data. One can take a call. If I use this one only as my old method, my cost of foundation goes up. If I use this one, well, I'm afraid my structure may have some issues. So this. Now let's come to it. What we decided is we took about 40 to 45 ton per square meter against 30 ton square meter. Then we had increased it by 50%. And the settlement we were expecting in the range of 20 to 25 millimeter, which is absolutely within my tolerable limits. It resulted in foundation performance within the permissible limits, economy in foundation design, and with the reliability. Well, the performance was also confirmed with the notice results. So now you can understand that the kind of the saving we could achieve with the inclusion of certain tests. Now, this is how it looks like after the construction. Most of you must have seen en route while going to your Himachal. Now, let me take you to the number 2 case study of a hydrocracker unit at Panipat Refinery. Again, this is the layout drawing with the various locations. We have done boreholes, pressure meter tests, and then we have done also the block vibration and other tests. Well, as you know, the any refinery structure, they are very heavily loaded. They have the dynamic loads also. So they have a very restricted settlement criteria, like the total settlement not to exceed 25 millimeter. Well, whatever we had, the boreholes and the static cone and pressure meter test and the block vibration test. Now here is your field SPT value versus depth. You can see how it is going down. Then you have the corrected SPT value. So far, this is the normal, with the borehole data. This is exactly what we've been doing. Now this is with the static cone, the code QC values, code tip resistance, and the friction ratios are all plotted here. Right? Now this is the combined plot of the cone resistance. You can see the kind of the variations, right? Now these type of variations are very much expected and natural in the case of the alluvial deposits. Well, these are the results for my pressure meter test. Unfortunately, it was carried out only at 3, 5, and a 10 meter depth, not below that, as per the final conclusion of the consultant, I would say, or the project authorities. So you can know all these things. Now, if I plot them, the pressure meter profile, the limit pressure, and the deformation model. These 2 things we have plotted. Now you come to the design profile, right? Now the soil classification, we have this classification we have taken up, from my borehole data. These are the SPT values for borehole data. These are the coal penetration test results giving the QC values, and this is the limit pressure. These 2 values only from my pressure meter test. Again, you do the analysis for the open foundation at 2 or 3 meter foundation width. Now we have a net reliable bearing pressure of 5.7, and with the classical theory, that means using the 10 value, you get 24.9, 25. 25 is my restriction, right? So accordingly, you get a static code gives me these, pressure meter gives me this. Again, as I mentioned in our Khalsa Heritage project, here you again have a lot of variation. So if I use this classical theory, that is SPT, and these values, my cost of foundation will be enormous, right? Whereas in this one, it may come to 50%, here it may come to 25%. But we do not know how to go about it. Let's go move forward. Now, similarly, for the pile foundations, we go out for the board pile and the trivet piles, the different length. C5 from the lab data is this value, interpreted as static code and a pressure. Again, you will find there is a good amount of variation. Right? So, you would understand that by using these 2 other methods of the static cone and the pressure meter, we can really give value engineering and economize my foundation designs, yet without compromising onto the serviceability criteria or the factor of safety. How you can do it? Because you are reducing your factor of ignorance. Right? You reduce your factor of ignorance, you increase your factor of reliability, and that's how you're able to do a much better foundation design. Now let me talk to the third one, which is a metro project in Delhi. This is in the vicinity of a heritage structure along Delhi metro alignment. Right. Well, the typical range of the values of the different parameters are here. I mean, as per the borehole data, right? And this is where how is my pressure meter results. You have a pressure meter, volume change again. You have the calibrations here, the field curves and the corrected curve, right? The tests were done at 5 meter depth interval in NXI boreholes were recorded to assess the limit pressure and the deformation modulus. Now here it is. You have the limit pressure deformation modulus. This is at a borehole number one, location 1, PMT1 as we call it. These are the N values, and you have the limit pressure, the deformation modulus. Similarly, this is at the second location, right? Now you can see this, of course, limit pressure I've already said, deformation modulus. Again, the same thing, limit and the deformation modulus, right? So now you can calculate undrained shear strength of the cohesive soil, right? Because it's based upon the cavity expansion theory. So you have the undrained shear strength. We have that also. We are trying to plot with this with depth, depending upon my PMT results. You know, this one is for my PMT1, PMT2, and the red dots are for my laboratory undrained shear strength values. So you can see that they have been matching fairly well. Rather at a deeper depth, it has come between the two, right? But it shows that yes, we are very much onto the right track. Similarly, the consolidation parameters, because it can be correlated with the pre-consolidation pressure and undrained shear strength of clays as followed. The equations are there from class. Now, what we have done is based on the pressure meter we have done. You remember in my earlier slide I mentioned that what we can use pressure meter, besides the consolidation parameter, the pre-consolidation pressures and all those things, right? So based on the pressure meter, this is what we are getting as my pre-consolidation pressure. And these are the values as per the consolidation test results in the lab, which slightly shows a lower value, right? Now again, this is the over consolidation ratio as based upon the pressure meter result and as obtained from my lab results. So that means that all these correlations, whatever have been established, could be, very well correlated here in our Indian scenario also. Similarly, in situ horizontal stress, you remember we talked about it. So here also the same thing, in situ horizontal stress, when we calculate from the base of the pressure meter LCI, right? And also assuming as a K not equal to 0.5. Same thing here. For both the boreholes, you see, because the site is close to red port where you see there were certain restrictions. So we could make out all these things. So that means the pressure meter result is getting fairly well correlated. Now this is just a summary of the various test results. That how the shear strength, consolidation, and the in situ horizontal stresses, right? These are soil classification, these are the N values, level pressure, deformation, undrained shear strength, pre-consolidation, overhang, in situ. I mean, all these things one can make out in a tabular form. So you have complete analysis with you. Right? Now with this one, okay, so now I will start with the conclusion. The pressure meter test is a reliable in situ test to assess the geotechnical parameters for design, as we have already seen. It was developed by Menard in the 1950s, and it is a superior test to evaluate foundation behavior. It estimates bearing capacity, settlement, pile capacity, etc. are realistic. and closer to the actual values. More advanced testing techniques such as pressure meter, statico, dynatometer can revolutionize your foundation design. The test can be used effectively to economize foundation design without compromising on factor of safety. Why? Again, I would say because we get higher factor of reliability. The benefits are for incorporating that in the investigation program are enormous. Well, sufficient pressure meter test should be performed to justify use of high bearing capacities. Just doing the test is not enough. Correlating with other tests and soil parameters to develop economic and safe design is essential. And also, that we should have a trust in our parameters. Additional cost of doing the test is very small in comparison to the savings that can be achieved. 3 case studies have been presented to illustrate the application of pressure meter tests in conjunction with other tests to develop a reliable and safe foundation design. You see, we need to model characteristics of a strata. Why? Because we are now looking for a high factor of reliability and not high factor of safety. Do not forget, any improper data or misinterpretation can lead to foundation distress, which will result in settlements, might be total settlements or differential settlements, failures, shear failures, or with the serviceability criteria by reducing your factor of safety. Remember, as I mentioned in the beginning, that no two human bodies are similar. No one medicine can treat all kinds of the ailments, right? If I got a fever, if I need aspirin, you may not require aspirin, you may require something else. Similarly, our no two sites are the same. Our soil characteristics, the deposit strata characteristics are varying from site to site. Depending upon the nature of project, my stress levels are different. So if the stress levels are different, my strains are different. So my analysis, requirement of parameters, and the usage of any particular clear testing method has to be evaluated accordingly. That is the crux of the thing. That's why we say geotechnical engineering is a science, but it's practice and art. Stay safe and healthy. But I think there was one message which I was giving. Have I? Yeah, this one. Sorry, I think there's one message which I want to give to all my, my colleagues as the various students from various institutes. A geotechnical engineer has to become one with the soul of the foundation system. You have to be a part of the soil, feel the stresses, deform along with it. The solution to the problem will emerge from within the foundation itself. This was the message. I think I was skipped on to that somehow, but nevertheless. Mr. Neeraj, sorry, I took a bit more time because of the
no problem, sir.
In
In
the
fact,
inputs.
it was a very good lecture, sir. It was very nice to hear that you compared everything between 2 or 3 different tests also. So you started from the very basics and went to show some field case studies also. So that was a wonderful lecture actually.
Thank you, sir.
So yeah,
Just to show them, I will not go through this thing. These are the established, as I mentioned, undrained shear strength of the clay. I got the equations, to determine that. We had the equations. Of course, I mentioned about the consolidation parameter, but this is how one can calculate the consolidation, this thing, a pre-consolidation also. You can also do that, the in situ horizontal stress based on the cleat per volume. We know the shallow foundations also analysis. I mean, all these things are already established. I didn't cover into the main slides considering the time. I can do the analysis, settlement analysis. You can do the, the pipe capacity, deep foundation analysis. Everything is there and well documented over a number of years now. So with this one, I pass it on to you, sir.
thank you, sir. Thank you very much. Sir, with your kind permission, can we go to the query round?
Oh, yes, why not?
Okay, so we have some questions up here. First one is from Yashpal Shardaji. He's asking how much is the pressure meter test successful in case of rocks?
Well, Mr. Yashpal, right?
Yes, sir.
Yeah. Mr. Yashpal, as I was mentioning, in the case of the weather rocks, severely weather rocks, where you have a core recovery as 0% or 5%, right? This is the one test which can give you some parameter to rely upon. Otherwise, you have got no other parameter. You tell me what other parameter you will have if your micro recoveries are severe. Yeah, I mean, in so many specifications, they say you conduct a SPT, but
So there is an extension of
sorry.
yes, there is an extension of the same question, I suppose. Yes. How much? Yes. Which test should be referred if the strata consists of alternate layers of sandy and clay soils?
What type of test means? Sorry.
Yes. Which test should be preferred if the strata consist of alternate layers of sandy and clay soil?
Well, you can do a SPT you are doing, you can do pressure meter test, or there is no harm. You can do static cone also. You see, the moment as far as you are understanding your stratification, right? I can use in pressure meter advantages, you do have a soil sample, you have just before the test section, you have taken out a soil sample, you know. So once you know the classification, you know that which correlation to use, right? A static cone also one can use, of course, and a static cone also with the friction ratios, one can determine, the soil classification, but again, that may be slightly approximate, but one has to use a judgment also. You see, ultimately, I say one thing, when we call that, it is a science, but it's practice and art. Ultimately, you look at all the various parameters, and then you have to take a call on to it that which one you want to use, right? I mean, like the doctors, they get you done, 80 tests, and the doctor reviews the test. He is not using all the 80. He just uses, the which one is giving him the more, I would say, the accurate parameter for the treatment.
Okay, sir. Thank you. I
But
will request.
Mr. Shada, have I clarified the point? No.
Yeah, thank you.
Right, Mr. Shada. Nice to see you again and again on every of these webinars. I'm very happy.
Thank you.
Thank you very much, sir. I will request other participants also to ask their questions in the chat box, or either they can raise their hands and we will call the name and they can ask their questions directly. Okay, there is another question from Adiki Purandar. Sir, this pressure meter works in very sensitive soils. What is the minimum pressure difference we can measure?
Very good question. For limit pressure, you can measure, I think the minimum is a 1 bar.
Okay.
But in the case of a sensitive soil, I would prefer to go with the in situ weight share test, because then I can know my sensitivity ratio also. Degree of sensitivity I can measure if I'm doing in situ weight share test.
Okay, sir.
That's going to be the advantage.
Okay, sir. There is another question from Avik Kumar Mandalji. What are the special cares to be taken while conducting the pressure meter test for various ground conditions? May please discuss.
Yeah, Mr. Avik, I think you missed out one of those slides, with this hang up of the net issues here in the office today. I had mentioned you can do in the sand, suppose in the sand, because of the collapse of borehole, one test, one level, for one test, you may have to repeat it 2 or 3 times in different sections, right? So your cost of the testing goes up, I mean, in the terms of the time required or time taken by your team. Similarly, in the case of the weather rock, as I was sharing with Mr. Shada, what you have, the only issue is that the membrane get damaged in the weather rock formation. So your cost goes up. Otherwise, one has to take care of the because this is a very sensitive test. So one should be very careful and do it carefully. That's all.
Thank you, sir. Thank you very much. We have some questions from the students also.
I hope, Mr. Abik, I have answered your point, or is there something which I missed out?
It is okay, sir. Very fantastically explained. Thank you so much.
Thank you, Abik.
Thank you, sir. And thank you to Professor Bashir Ahmed ji for that appreciation. There is another
Thank you,
question.
Bashir. Nice to see you in every webinar. Now we cannot see you physically, but at least through webinar we are able
Yeah. Basically, that's all the things are found very much interesting and useful. That's why somehow within our busy schedule, I am making out time for attending these ones. Thank you, sir.
Good. I hope you are keeping well, Bashir.
Bashir
Good
ji.
evening, sir. Can you hear me?
Yeah, I can hear you. I hope you
Very,
and
very
your family are
insightful, very interesting. Though I joined little late, I was busy in a meeting. It's very interesting and fruitful to the readers and researchers.
very good. Thank you. Now, what I was saying, I hope that you and your family are keeping all good.
Yeah, all is well. I hope to everything is good and well at your end also.
Very good. And your Srinagar is also safe and
Yeah, it's safe now. It's safe.
Safe
Now,
and
school is
fine.
open. Offline classes are going on.
Oh, very good. Yeah. Then I think I can make a plan to visit.
Yeah, of course, you're most welcome. I'm actually planning this webinar, and I may request for a lecture also. Just I am arranging the things.
Okay, anytime. We are always there to share whatever little knowledge and experience we have gained over the.
Actually, these field tests are very important, and they have to play a very active role. We need to discuss them with the students as well.
Right. Thank you.
Thank you, sir. Thank you very much.
Thank you very much, sir. We have one question from a student. In what kind of formations do we need to go for higher pressure in pressure meter test?
Sorry, I couldn't get it, please.
Yes, in what kind of formations do we need to go for higher pressures in pressure meter test?
You see, if you expect that your strata is going to will require limit pressure of more than 80 bar, then you take a 200 bar capacity of the equipment.
Yes, sir, I must clarify. He's asking about what kind of stratum, what kind of formations do we generally need to go for a higher pressure?
Hard soil, soft rock.
All right, sir. Thank you.
You see, in the case, yeah. I think maybe I'm not very clear with this question, but does it answer it?
Yes, sir. Yes, sir. I think you did mention in your slide as well.
Yeah. I feel I can't see his.
It's not on the chat box, sir. It's with me.
Okay. Yeah. Okay. If we could just speak, if we could speak out, then maybe I can understand his query and answer better.
Maybe yes. It's coming on my WhatsApp, so I'll.
Okay, no issue.
Okay.
In case he has got any other issue, he can always connect with us.
Yes, sir. Yes, sir. Okay, there is another question, sir. How to perform the test in case of a sandy collapsible soil? It's a collapsible sand.
Well, it is a challenge by itself. We have been doing on a certain sites, right? So it takes, for one test, maybe you have to do a 3 or 4 times a run. Maybe you use a bentonite slurry to stable it. You see, above the test section, you can have the casing, right, to keep the borehole intact so that your probe does not get lost. But at the test section, you cannot have the casing. So it requires very carefully doing the boring and then conducting it. Recently, we were doing it, in the river bed, okay, and as a sandy soil all through with the water table at ground level. And in the initial stages, in the first 20 meters from ground to 20, every test we had to repeat 2 or 3 times before we could get the right results. Every time there was an oversize of the borehole, so the probe, without any increase in the pressure, your volume is increasing of the probe. That means my bore is oversized. But after 20 meter, because of the overburden and the slightly, the denser soil, it was possible to do in the first attempt. But in the beginning, we were doing a 2 to 3 attempts in one test.
Positive net 3.
Yashpal Shardaji has raised his hand. Sir, if you want to discuss something.
Yes, sir.
Sir, you are muted, sir.
Sorry, sir. How do we decide how much pressure has to be applied?
So you don't decide, it is the soil which is going to decide. Because you are giving the pressure in increment and you are measuring your volume change, right? Supposing I start my test say at 1 kg per centimeter square, you have a volume change, right? After that, then you increase it to 2 kg, then you go to 3 kg, like that you keep on increasing. Now you already have an idea whether it is a loose soil or a medium dense or a dense. So you can take your one, because ultimately you have to plot with the different pressures you are measuring the volume, and then you come to the limit pressure. Right? In the one of those graphs, you remember that you have a limit pressure and the volume change. As you increase the pressure, your volume is increasing, then it comes to the yield point. That yield point is your limit pressure.
Oh, thank you.
Yeah. Thank you, sir.
Thank you, sir. There is another question. What if standard penetration test and pressure meter test results differ? Then which one is to choose for design?
This particular point I had mentioned, I think, repeatedly in my presentation. These values, you remember that I had shown you my correlation with the, E values also with the SPT and what we got from pressure meter and a static code from the two different project sites. One was in Orissa and one was in UP. So there is a variation. Then with the case studies, I've also demonstrated that with the SPT values, what analysis you get with pressure meter or static code. Ultimately, one has to take your own judgment that which parameter I want to use. That depends upon your own confidence level of the analysis. That's why we always say, though geotechnical engineering is a science, but it's practice and art. It is not something that, that 2 into 2 is equal to 4, you can everywhere you can fit in. Like in the human body, no medicine is suitable for each and every disease or every person. The same is the case in the geotechnical engineering. So you have to say, if you feel that you are more reliable with the pressure meter results, you use. Then again, as I showed you, I think in one of the cases that was showing 3 times value, right? So even as a geotechnical engineer, I feel that if I give them a recommendation for 3 times, the client may not accept it, right? So we have to come closer and closer in the gradually. That's what we are trying. We are trying to establish all these advanced testing techniques in the last 25 years by demonstrating at various sites. But still, if we are, mindset is to go back to the old days of the, the borehole ka le lo, SPT le lo, UDS le lo, plate load test le lo. So we are having a tough time, but we have to move forward. Like I think most of you must not have used slide rule, right? When I was a student, I have used slide rule. And this calculator came much afterwards. And nowadays, all the students, they are starting with a laptop, right? If I ask them about a slide rule, nobody knows a slide rule, how to use a slide rule. So the same way, we have to change in the practice also. Geotechnical engineering is what I would like to say.
Thank you, sir. It was very well explained. There is another question from Adiki. For clay soils, the resistance offered by the ground is different when moisture movement will change. That is, in dry season, the resistance offer high resistance, and in the monsoon, the resistance is lower. How for these CPT and PMT tests will be reliable?
Well, the same way the reliability factor, Adiki, will be like the same way like your SPT. As you do a borehole in the dry season or a wet season, below water table, above water table, whatever is your reliance factor in the SPT value, the same reliance factor comes in. And of course, I know that I'm doing it under a dry condition. If I have to apply my analysis for a saturated or underwater conditions, I will be using those parameters, correction factors.
Okay, sir. Thank you very much.
Mr. Aditi, is it okay?
Aditi man,
Have I answered it or something balanced?
no. I hope it is answered. I think she
Well-
cannot unmute herself. Any other participants, if want to ask any question, they are free to ask. Okay, there is another question from Ankit Unyalji. Can we compare the PMT data with cavities?
Very good question, Ankit. But tell me one thing, if there is a cavity in the rock mass, can you do pressure meter? You can unmute yourself, Ankit, and reply.
Am I audible?
Oh, yes, absolutely.
No, sir. See, if there is any decrease in core recoveries and there is a possible cavities in the area, can we calculate the amount of cavity, like area of the cavity, with the low results? Is there any correlation?
Not with
Well,
pressure meter.
not with pressure meter. There cannot be a correlation to it directly.
Mhm.
But maybe if you feel there is of course, this is a rock, that much volume change should not be there.
Mhm.
But still, if the volume change is there, you can estimate or make a judgment that there may be some cavity or something.
We can calculate from Pracker test actually, but I don't know about the PMD test.
I have my doubts.
Electrical resistivity
Imaging can do,
Okay.
like what we did in that South job.
Kochi.
Yeah.
Okay, sir.
Okay, sir. Thank you very much. I don't think there are any other queries remaining now. So with this thing, I'd like to thank you, sir, for a wonderful share of knowledge and your immense experience as well on pressure meter test. And it's really have been a wonderful session, I would like to say. So I extend my sincere thanks to entire IGS Shimla team and also Cengrs Geotechnica community for making these sessions possible. I would also request audience to please fill out the feedback form before leaving. And we'll be meeting on next Saturday on 9th of October at 3:30 p.m. where we'll be joining once again with our inaugural speaker, Mr. Ravi Sundaramji, Director of Cengrs Geotechnica Private Limited, who will be giving an insight into geophysical testing in geotechnical engineering. So with this, I'd like to thank you to all the participants and to our guest speaker as well, and other persons from the industry who have joined us in this session. Thank you, sir. Thank you very much.
Thank you. Thank you all. Thank you very much.
Thank you, sir.
Yeah.